All right, welcome everyone. Thanks for coming. Thank you for coming out late in the day to talk about this here. So I think one of the things you'll notice about this title is it encompasses pretty much everything you could possibly want to talk about blockchains ever. So we're not going to talk about everything because it's easy to spend a lot of time talking about various scaling solutions, various strategies for building a decentralized economy, arguing over the word decentralized, arguing over the word economy, arguing over the word blockchain. There's lots of things we could talk about here. So instead, I think we're going to start off by focusing.
Where's the best uptime?
Oh, yeah. We could always talk about uptime. That's one of my personal favorite subjects. So if you can't joke about yourself, what are you doing here? So that's actually a great place to start. I want to talk a lot about design decisions, trade-offs. Everyone's approach to scale in any piece of software always has trade-offs. There's no such thing as a piece of software with no trade-offs. Someone at some point, or a group of people at some point, made a decision to say, we're going to build this thing this way, and we're not going to build it another way. So, for example, right, Solana, a lot of the design decisions made on Solana are to maximize throughput at sometimes move really quickly with software development. And sometimes that's not the right decision, right? There's been periods of congestion on the network. There's been several outages on the network. That's a design, and I'm starting off as the one being vulnerable here to invite the fellow panelists to be equally vulnerable. Yeah. But that's a design decision that was made in the process for the community to say, like, going fast is and having that failure state be one where the ledger is secured, even if it's publicly very unfortunate, let's call it that, is a design decision that's been made by the folks building the Solana network. Every single network has different design choices and decisions made, so I want to kind of talk about some of those that maybe didn't go so well, or maybe some of the trade-offs that are built into how you're thinking about building and scaling software, because today, as it exists, there's no piece of decentralized software that can support 100% of the volume of all the world's transactions. As much as someone might want to tell you that, at best, we're looking at theoretical numbers of 1 million transactions per second, and that is not a number that is big enough for all of the world's information. So no matter what we're talking about in scale, there's phases of scale, and it might take 10 years to reach true global scale for any possible solution on stage, not on stage, or one that comes in the future. That's kind of where I want to start things off today. So let's kind of start at the beginning there. How are you guys thinking about scale?
Hey, everybody. Adeniyi from Mysten. We're the team. We were working at Facebook for the last 3-4 years building the Libra blockchain. Obviously, Libra isn't here with us today. And
rest in peace.
Rest in peace, Libra. But we learned a lot of great things through that experience. And I think one thing we actually did once we left Facebook is tore up the work we'd done for the last 3-4 years and did a new design entirely because we had learned a lot through the process of building Libra on how to actually build a system that would tailor to the billions of people of the world. We took a very complex approach to solving scalability, namely, unlike other protocols that have a single consensus algorithm, we actually have two. Right? We have one for single owner objects, whereas when I transfer you water and you transfer someone else something else, those are two different transactions. We can parallelize those, add more CPUs, you go faster, and then we have a different consensus algorithm for shared state. So when you're trading on a DEX, there's a different consensus algorithm for doing that. That's actually very complicated. So we're building two blockchains at the same time, and we're welding them together, which is not the most optimal thing you want to do, but we felt it was the right idea at the time.
Right. So there's two trade-offs that you just brought up there. Yeah. The first is to say, the code base that I worked on for 3 or 4 years, we're going to throw this away, we're going to take learnings and build something new. The second one is we're going to build a complicated system.
Correct.
And the more complicated a system gets, the more likely there is a problem that can't be found in testing, just has to be found live. Like, walk me through a little bit of how you and the other co-founders thought about that process when you were designing Sui.
I mean, luckily we're not live yet. We're still building.
Theoretically.
We're in DevNet, testnet in a couple of weeks. So the way we're thinking about it is really slow and steady, but we're willing to take some risks along the way and add core functionality as we progress, right? Like, you can't build it and expect it to be 100% perfect on day one. But what you can do is make sure you have the mass majority of functionality available for builders. The biggest thing we did is really made object-oriented language for smart contracts. So if you are a programmer in in C#, Java, you can come to SWE and build and move with an object-oriented move very, very quickly. So we took the element of redesigning a lot of core elements of move to give developers a much more improved developer experience at the cost of launching way sooner. I mean, we could have gone to market with Libra and be live by now, right? But we took a very different approach from that perspective.
So I'm curious, and we'll get to everyone, but as we're focusing on something like Move, right? A programming language is an advantage until it's a disadvantage, right? Like COBOL was like the coolest thing for a while, and now and now you look back, and that's why like the U.S. Unemployment system couldn't meet the demand it needed during COVID because it was built in a language that had zero scale potential and had fallen out of favor. Like when you're looking at a language choice, right? Walk us through a little bit of that process too.
Look, ultimately, when you're talking about smart contracts, you're talking about programming scarcity at the heart of it, right? And programming languages were not designed to deal with scarcity natively. So you have people building a lot of boilerplate code to deal with verification, which is where you get a lot of the hacks and the bugs that we have today, right? So with Move, it was designed, I mean, when we wanted to go to regulators, we can't say trust us that it works. We had to build something that had an element of functional verifiability into the model. So we have a language now that's functionally verifiable that actually has the element of verification directly. So if I transfer you an asset, you don't have to do all the checks to make sure it's left the account and the balances are correct. It's done by the runtime. So that was a design decision, because when you're programming scarcity, you don't want assets to be destroyed or duplicated in any way. And that's what a lot of smart contract platforms force the user or developer to have to build that in. And we didn't want to enable those kind of mistakes.
Yeah, it's super interesting because in some ways it makes development easier, but then you're also choosing a lot of guardrails that you'll see. Like anytime you build in a more abstracted system with better protections, you also in some ways limit what can be built in it, which is an interesting decision, right? So, so Staci, when you're like, we were talking before around some of the verification systems that Algorand uses and its ability to scale because of that, but that the transaction finality time is maybe a little slower than you might see from some of the other systems. Talk a little bit more about some of those decisions and how you've approached scale.
Yes, well, when I built the Algorand blockchain, as a Turing Award winner in computer science and a tenured professor at MIT, one thing I will say about Libra, though, first, is I think the fact that Libra could scale is actually what brought down its demise. From a political and a regulatory component. The idea that it could end up being a regulation maker instead of a regulation taker. And it was powerful enough and scary enough to kind of maybe sow the seeds of its undoing. I don't know, but I think that's a reasonable theory. So Sylvia Macaulay is the founder of Algorand, and he was intrigued. He had kind of invented or co-invented a number of things that are very important for the crypto ecosystem more broadly. So those are zero knowledge proofs and verifiable random functions. So I think he was watching this, but he never attached the idea of money to these things. That was kind of not how he was thinking about it. He was thinking about it as a cryptographer. And Vitalik Buterin, famously posited the trilemma that you can't have scale and security and decentralization at the same time. And I think he said to himself, I think we probably could. And as you guys all know, everything, all the juice in a blockchain is in its consensus mechanism. So he developed a pure proof of stake mechanism. And just at a very high level, it kind of works like this. Final settlement finality without forking. It's impossible to fork. It's not just that it hasn't happened, it's impossible. Does take place now in 3.9 seconds, Austin. So we have just released the new version that goes from 4.5 to 3.9 without the possibility of forking. I think that's pretty fast, particularly for sort of high value transactions. And consensus takes place in 3 rounds over the course of these 4.5 seconds. And the number of algos that you have improves your chances of appending the next block, but does not guarantee it. So that's where the randomness comes in, built on these verifiable random functions. And so it's random and also deterministic. So the reason it's secure is because the vector of attack is not known beforehand. You don't even know yourself if you're going to get picked. The more algo you have, the greater the likelihood that you'll be able to propose the next block. And so this happens over 3 rounds. The first round you propose the block. The second round is a soft vote. The lowest hash function will end up getting picked. It takes some time though, and there's kind of a natural, maybe hard wall there, because you've got to get to all the relay nodes, and they've got to be able to compare all of the different proposals and go and select the one with the lowest hash function. That will take some time, because you don't want a lower one to come in after you, right? And then the third round is where you check for, like, is there a double spending? You kind of check the integrity of the block, and then it repeats every 4.5 seconds.
Yeah, it's interesting because there are models on several chains where you have sort of optimistic confirmations, and then you move forwards. And on Algorand, there seems to be 3 layers of that, which is like moving confidence intervals up at each stage, if I understand that correctly.
Yeah, the third looks at the transactions and make sure the transactions are okay, and the first 2 kind of propagate and then verify the block.
Yeah.
But if I could, you did ask something about kind of language trade-offs, and I think that they made, and of course I don't speak for them and I wasn't there exactly, but I think the machine language of Algorand is called Teal, and I think that Silvio in the early days and the engineers decided that the real fork in the road, really, honestly, if you want to build something quickly and deploy quickly, is, are you going to use Solidity or not? And so I think they decided that they were going to use a language that was harder to learn and less tolerant of mistakes. It's the kind of language that you fly airplanes in, not the kind of language that you would, program Facebook in, right? And as a result of that, it can scale to whatever I'm not throwing shade at any Ethereum, but sometimes your success can a little bit be your demise, right? So this is a little bit harder to learn in the beginning, and especially in the beginning. Now I think they've solved a lot of those problems, but that was an explicit trade-off that they made. That we're not going to be able to just import thousands of Solidity developers. We're going to make you learn something else, and that language will be able to grow with you, and you'll be able to scale to what you want.
Yeah. So Eli, I want to talk about one of the most interesting trade-off decisions that someone can make, which is relying on someone else's base layer.
Yes.
Yes.
Yeah, so...
Talk to us a little bit about that process of deciding. I mean, the idea of roll-ups in layer 2 systems is one that's been floating around for a while. There's a lot of systems that have been built, but it's sort of that old adage of you don't want to build your business on someone else's business. Right? And that's like a very Web 1, Web 2 way of thinking about it. I don't think that applies to Web 3, but it means that, certain things like your timelines are not necessarily your own. Like, would love to kind of talk a little bit about that with you.
Yeah. So, we founded StarkWare 4.5 years ago. It was right in the craze of the ICO season. Everyone was saying to us, and the investors and everyone saying, hey guys, you have to they didn't call it layer 1 back in the day.
Yeah.
You have to do an ICO. You can raise $1 gazillion. It's the obvious thing. It was the happy days. EOS was launching, Filecoin, Tezos. And we said, there's this cryptographic technology that we know very well, and it makes a lot of sense. And the fact that we are bringing this technology to fruition doesn't mean that you should have a new coin for it. By the way, I'm gonna, those who follow us know that by now we actually are launching a token, but I can explain why it makes sense now. But back in the day, it didn't make sense. We said, we have this technology that is very, white label in the sense that it can go anywhere and scale any blockchain exponentially. By the way, it can also go outside of blockchain and help scale exponentially. This technology just delivers integrity in a novel way and in a much better way. And as Staci said, indeed it is based on the foundational work of Professor Silvio Micali, who's founder of Algorand, and what we did was improve a lot the efficiency of these things, which were considered impractical initially. So we have this core technology that does something really well and can amplify exponentially the scale of any system on which you have trust.
So let's dig into that a little bit though, around that's a big claim.
Yes.
Right? No doubt. And with every big claim comes decisions that have been made that say we're going to be really good at this piece and we're going to be less good at this piece. What does that look like for StarkWare?
So for StarkWare, we're really good at future-proof scaling through Starks, which is also the future-proof way to do validity proofs.
Yes.
So this is something that is post-quantum secure, has the fastest, proving time, can scale to any scale without any need for trusted setups or things like that. So it's going to stay around for a while. So this is the thing we want to get right. And furthermore, we want to get it right and deliver the utmost scale in the hands of developers in the best way, which is also why we ended up inventing a new programming language called Cairo, which is another decision that we made. All of it is to serve this purpose of giving developers the most scale in your hands in the best possible way. So one thing that was very easy for us to say we don't need to go there at this point in time is to say reaching, doing things like consensus in the base layer. Others have done it very well. We basically said, and we're still saying, this is a technology that any blockchain as layer one and later on, the conventional world as well, that needs scale to go beyond its perimeter of trust is going to use it. And okay, Bitcoin was the obvious place that you would want to deploy, but on Bitcoin you can't deploy because it's not Turing complete. So the second obvious place to go on is Ethereum, which is why we went there. It needed the scale. By the way, when we started our path, we said to everyone, scale is going to be a problem. And people said, no, it's not a problem. And we were still working on scalable technologies back then in 2018. Lo and behold, it did become a problem. Now everyone's talking about it. Luckily, we started, back then. So this technology will go on any infrastructure that needs scale and wants to have integrity at scale beyond the perimeters of its place. So, yeah.
Sure. But in that model, right, there's a whole bunch of different systems involved in any sort of proof, right? There's off-chain technology involved in actually computing that and bringing that back on-chain. There are points of censorship around all of these types of technologies, right? Famously, if you're running a single sequencer, not that people are necessarily, but like in a ZK rollup system, if you're running a single sequencer, that is a choke point, right? Both of throughput and of centralization, potentially, right? There's a lot of these types of things where most solutions that revolve on Starks break composability when you move between layers, right? Those are sort of like the world that scaling solution is built in has a thesis behind it, that a bunch of transactions are going to be of this type or maybe not of this type, right?
So for us, it was first utmost scale with a future-proof and very scalable technology. You're right that decentralization comes later. It is something that within the next year will be solved to a very satisfactory way on both the sequencers and the provers. It will be decentralized and open, and it's not going to be single point. And you're right that these are things that come second in our prioritization.
Sure. That's what we're here to talk about.
Yeah. So first we want functionality, scale, of course security comes first, and decentralization is going to come next.
Don't let him push you around though, Ellie. You stick up for your priorities.
What?
Don't let him push you around. You stick up for your priorities.
I think, the developers of StarkNet are very happy with these things, and they accept this and they understand the reason we went there, and so, yeah.
Yeah. So I want to talk about EOS network as well, because back when I was working at Bison Trails, one of the networks that we were working on archival support for was EOS, because that was something that there was some demand for from networks there. And I believe at the time, this was like mid-2020, the volume of data generated by the network meant that ledger and trace data was over 60 terabytes that had to be indexed and maintained in order to support that, because of the volume of data moving through that. There's obviously a scale decision made when you're talking about a system that both can pump that much data through it, but at the same time requires that much data to run. Would love to dive in on some of that decision making there.
Yeah, so what you're talking about, that particular time, the EOS network was roughly doing 125 million transactions per day.
Yeah.
To put that in perspective, in every single day EOS was doing more than all other blockchains combined. And if you looked at Bitcoin and Ethereum, it was doing more in one single day than Bitcoin and Ethereum for the entire year.
Sure.
So, that is...
some numbers, generally Ethereum somewhere around 14 transactions per day on the or per second on the base layer. Bitcoin's around 7.
So it's an immense amount of data to be able to process, right? And that's one thing that EOS does extremely well is that scale, but that comes at a cost. So during that period of time, and to keep it kind of on point, the idea was that the ones that were actually providing that service, their cost was increasing significantly. And if you're talking about the ones that need to, because obviously we're in blockchain, we want to have that immutability, we want to keep that record, right? So you want to have history nodes. In our case, those history nodes were bearing the brunt of that cost. The amount of data that was being captured daily and that needed to be stored daily during that period of time, which roughly lasted for about 3 months or so, of 125 million transactions daily, nonstop. In order to be able to store that data, there was no incentivization model for those history nodes to be able to provide that. So what we saw as one of the downsides is that a lot of those that were providing that data up until there, or without storing that data up until there, had to stop. And so the amount of nodes that were storing all of the history nodes essentially went down significantly. And for a period of time, we only had maybe 5 or 6 actual full history node providers that were doing so as a public service. And so we needed to build around that. And so we re-engineered and we re-architectured how that data was being processed, what was being stored, how it was being stored. So we're really pushing the limits at that point, not even of what blockchain could handle, but how it typically even machine and data enterprise centers were able to handle in the blockchain space. And so it was quite tricky. So it was one of that double-edged sword, whereby do you allow all of those transactions, and then the community at that time was starting to have very real conversations about, do you what do you store? Do you essentially end up storing everything because there's a cost? Do you end up not storing everything? But if you go the route of not storing everything, then do you lose some of that immutability? Do you lose? And ultimately, what that ended up being for us, anyways, it's called CPU mining essentially.
Yeah.
That ended up being kind of the base layer foundation for what we see now as GameFi. A lot of the games now that are trending on DApp Radar in the top 10 are CPU mining in DPoS chains, and so we still have a few of the chains that run on the software that we manage and that we maintain, that we develop, are still processing 25, 30 million transactions per day. But we 2 years ago re-architectured everything in order to be able to handle that. But then that came with some design decisions, some choices, as you said.
Yeah, it's interesting. I mean, so one of the design decisions that, for example, Solana makes very differently is a weak subjectivity chain. The accounts database is updated on a per block, as an as-needed basis per block. So it actually, the nodes don't have to carry the full history of the ledger with them, right? That's another great example of that's a design trade-off that was made on the Solana network to support it, you not having to have a 30, 60, 90 terabyte SSD bolted onto the thing.
Well, another one of those design decisions as well is RAM. So what we're facing in EOS is actually RAM limitations that are not even theoretical. They're at the point where Intel and AMD don't make architecture that can handle the amount of RAM that we need in the hardware that we run the chains on in order to be able to support that large amount of account creation, essentially. So RAM limitations right now are one of the challenges that we're facing, because the amount of, again, going back to GameFi, which Antelope, the EOS.io, the underlying software was rebranded to Antelope about a month and a half ago. That underlying software is run by multiple chains that are running a lot of GameFi. And what we saw in the last cycle is that you have tremendous amount of users coming in. So we're talking about tens and tens of millions of accounts being created in a very short period of time. All that being stored in RAM in order to be able to access in a very rapid way. And we're hitting the bounds of what current computational architecture can provide us. And then we have a trade-off. So do we keep using latest generation hardware more on the desktop level type of computing for the BP nodes, or do we go enterprise grade? If you go enterprise grade, you got a lower clock core speed. Sure, you've got multi-threading, which effectively everything is pretty much single-threaded anyways, and so you're not really using those cores, so that's the trade-off there. But you can have more RAM, Or do you go on the fast core clock speeds, you still are able to meet that high throughput, but now you're maybe pushing the limits of how many accounts you can actually create. And so that's what we're trying to solve for now, horizontal scaling in that sense.
You know, I think this has been cast also to date on this panel in terms of kind of technical decisions and technical trade-offs. But there's also business trade-offs that you make all the time and that drive the technical trade-offs. So for example, we just released an upgrade and now we do 6,000 transactions per second, right? But the head of product at the Algorand technology company says, you know, they have a roadmap that they theoretically know how to get to 10,000 transactions per second and then to 40,000 transactions per second. But they turn to the foundation and say, okay, well, where's the throughput? Though, right? Like, I mean, you get to the point where we need to react to what you're kind of, you know, what kind of activity you're driving on chain. And I think you have the, you know, a similar kind of situation you do with Aptos, and I hesitate to say this, but our two chains maybe do, which is that you guys are. And correct me if I'm wrong, of course, but you're much more you put things out there that might not be fully baked, and the community loves it, and you're super transparent about it. Hey, we're trying this. It might not be, you know, it's in GitHub. Like, what do you guys think? And we are, you know, we kind of make sure it's like right before and I don't know, you know, what is that? And then it's kind of like you versus Aptos as well, right? You're a little bit more. Right? Yeah. No, but versus, like, they're kind of like out there, and you're making sure it's right, maybe. And you know, who knows what?
Yeah. No,
it's a trade-off. Anyway.
I mean, it's a really interesting point because, like, I think one of the things that maybe a lot of people watching don't know is that the process of a Web2 company choosing to build on a blockchain is not a unmediated process, I think I would say. There's often a lot of, you know, meetings involved in someone saying, like, you know, we can just hypothetical Web2 company saying we want to build a rewards NFT system, right, for what we're building. There's going to be a lot of meetings with lots of different potential chains and providers and something like that. And trade-offs that make a network attractive for developers will often make it not attractive for those Web2 companies, because they look at something and they say, well, there's been periods of downtime for this, or an outage, right? And they can say, like, well, for our organization, the PR hit is not worth, even if we think that the technology platform might be better, you know, because we exist in a Web2 world with Web2 users, there's a PR trade-off there. So you're exactly right that, like, the process that goes into deciding how scale works is often as much human as it is technical.
Yeah.
I mean, admittedly for us, right? Like, you know, we're blessed from the position we're not first, right?
It's great to not be live.
We've been monitoring
I will say
what everyone's been doing. We had a great experience with DM, and for us in general, we designed a system that is multi-threaded from day one. Our system is multi-threaded. It takes advantage of scale. You add more machines, it's faster, right? Like, the idea that you can have a cap on throughput, and today your fee is $1, next week it's $5. You can't build a sustainable business model there. Today, you can't tell me I play a game for $0.01 and I can't play it unless the fees are really low. I think that's the element of cloud that is great that we've adopted with our delegated proof of stake system.
Totally. But at the same time, when you're running two different consensus models, you've doubled your failure possibility, right? And that's kind of one of these great examples.
Well, you also have greater, you know, for us, right? Like, you have one that's working, the other, you have more redundancy, right? Like, you know, sure. It's a system design we've taken that we think actually benefits us in the longer term. Sorry. Yeah.
Well, I was just going to say, what's interesting about this is that we're talking about hitting the limits of what's possible, right? Yeah. So we're all taking a different approach. In order to be able to scale, one thing that I think is really important to remember is we're pioneering a lot of things that nobody else has done before. So whether it be being comfortable with actually having downtime, but hitting that theoretical limit of what you can do, and as you say, it's that trade-off of being comfortable with that, or taking a different approach of maybe taking a little bit of slower approach of making sure that everything is stable. Again, it's that trade-off, but anything that we're doing essentially is really at the forefront of what's possible out there. And I think that's why I'm here. That's what's exciting to me, is that really this is such a nascent field anyways. It doesn't ultimately matter which direction we're going, it's going to benefit the entire space.
Yes.
Because looking back 5 years from now, looking back, a lot of what we've learned as individual projects will now be rolled up into perhaps new projects, or now it'll be stronger. Where we are today is nowhere near where we're going to be. That's,
Yeah.
that's what's really interesting about it.
I would say the voice I wish we had on stage with us is Cosmos. Because Cosmos's approach to scaling is fascinating, and it's been very ahead of a lot of so the Cosmos approach to scaling that I think is particularly interesting is that you have many fractured states in application-specific side chains and networks of networks, and you have this theoretical practical interoperability using IBC and these connectors. But what we've seen is that very few people take use of those connectors. And we've seen this too with the L2 and scaling solutions for Ethereum, with Optimism and Arbitrum. They don't have many users, even though they're able to offer things like much lower fees. And so as we kind of get into the end of this and talk a little bit more about that decentralized economy portion of it, are users actually ready for, I don't want to call it decentralization, but fracturization, right?
I think they are. So on our front, so EOS and I guess the underlying, Antelope ecosystem was very much decentralized. And so you have multiple blockchains that were running the same software stack, but that very much were competitors and were not talking to each other. In the last 8 months or so, when we created the foundation, one of the big things that we wanted to do was to create those partnerships with those other ecosystems. And so what we saw happen is that these, right now we have 4 partners in there, Wax, Telos, UX, and EOS, that have come together, started deploying funding towards IBC, which we're currently running between chains. So we all had our own separate communities, our own applications, our own ecosystems. We're taking the opposite approach, where now we're creating that interconnectivity in order to scale.
But are you seeing people
completely
use them,
opposite?
Right? Like the question is, are you seeing people use them?
Yes, because right now that was one of the issues, right? They weren't able to scale further than that, and that is the method that we're using to actually scale. Whereas instead of creating it at the onset, not having a user base and potentially kind of growing too fast in a way, we're having to do that by not necessarily by choice in order to scale. It's a very different approach.
Yeah. What have you found with StarkWare? Because you guys have been approaching this problem for a while, and the user side of things is a very interesting problem to solve.
Yeah, so the way we went about it with StarkX is to offer this, as going back to what we're good at and what we're so we're not about hype, we're about delivering scale to ones who need it. So luckily, or sorry, not luckily, we're very fortunate and very proud to have partnered with amazing B2C teams. For instance, Sorare, they have a user base of, I think, upwards of 2 million users that are basically using NFTs. These users don't even know that necessarily these are NFTs or are on Ethereum on a layer 2 on StarkX, but they are. Again, it's about delivering scale, not about necessarily the hype around it. Immutable X, with its multiple of amazing teams building on it, has a user base of active users of hundreds of thousands. DYDX, volumes right now already nearing $1 trillion of volume being traded overall. And TPS, there have been weeks where the TPS on StarkX has surpassed that of Ethereum, and on most weeks we surpass Bitcoin, and probably, I'm guessing, 10x all the other L2s combined. So I think, crypto Twitter doesn't necessarily know these facts so much because, as I said, we're not.
But they're still really small numbers, right?
Yeah.
At the end of the day,
they're huge numbers.
2 million is very small.
I mean, coming
2
from
million
Facebook,
active users.
But 2
using
million
NFTs on a game, those are not small numbers. I mean,
no. I mean, at best, we're talking about 30 million users a day signing transactions across the entire
ecosystem
right now.
I don't even buy those numbers.
Yeah, I mean, you've dealt with some large numbers.
I think let's be real, right? There aren't enough users in Web3. Right?
Yeah.
It's a small number of users. The use cases are mostly gambling related or DeFi related, right? In my view, DeFi is not a product. It's a building block or a tool, right? I think unfortunately we've led with a lot of that, and it's great. people have made money, people have lost money, but I think reality is the next cycle we need real applications with real users, with use cases that keeps them engaged and enticed for a very long time. I think there aren't enough users in Web3, which is why we maybe say we don't need the skill and solutions now. But when you start talking about gaming, when you have 100 million people playing video games and you need to transfer items in real time, when you're moving assets from AWS to now a public ledger, you're going to need real scaling solutions. And especially if it's not focused around like literally milking the most amount of money out of users, but giving them a new gaming experience that they never had before. That's our goal and that's our mission. I think it's going beyond the hype that we've had so far and bringing in real users. When we talk about 10, 12 million people, it's not a lot of people. Yeah, we're nowhere near real scale.
I would like to stick up for us collectively, though, if I may. First of all, every single one of us believes in a multi-chain world, right? I mean, you're the head of comms at Solana. How many times have you said, we are not an Ethereum killer, we're not trying to be an Ethereum killer? The same thing with us, right? We all believe in a multi-chain world. That's the first thing. Second thing is traditional finance. I mean, I was at JP Morgan in 2015 when we went from T+3 to T+2, and how many years did it take them to do that? And we all gave ourselves a big pat on the back, right?
Yeah.
And then, NASDAQ can do, so many trades per second that we can't even imagine doing at Algorand. But, like we don't close from Friday at 4 p.m. until Monday morning. Like we don't sit around waiting for the opening bell. You know what I mean? So you got to think about, we are really, to your point, we are pushing the envelope of these things. And, this is why I think we all believe in the Web3 proposition more broadly, right?
And this is maybe how it scales, right? So you bring in a really interesting point in terms of multi-chain. What we're seeing in terms of user base, the end user that are coming in, and to your point, we are nowhere near, if you wanted to replicate, so I don't think it was a jab at you, but if we're talking about hundreds of millions of users, we're nowhere near being able to do that, none of us at all, at any given time right now. This idea of multi-chain, that's because inevitably, if you're in a decentralized system, you will not be as efficient as a centralized system. You just cannot be. That is one of the premises, right? But you somewhat can be if you end up being multi-chain. If chains start interconnecting with one another, you might not hit the same amount, you might not be as efficient, and that is the trade-off, but you will bring about other value propositions that currently the current Web 2 cannot provide. And really that's, I guess, what we're all here about anyways.
Should we hold hands? Should we all hold hands? I mean,
I just want to say,
no.
There you go.
Kumbaya moment here.
What are you saying?
I got to say this. Look, already 3 years ago, we demonstrated in production we can process a TPS of 9,000 for trades, 18,000 for payments. We mint regularly millions of NFTs per block for immutable X. The reason we don't have billions of users using StarkX systems is not because it doesn't scale, is because the users aren't coming. But the technology is there.
That was not a comment around technology. That was a comment around just there being so few users. But
okay, agreed.
Well, our time is up, but thank you all for sticking around on this late afternoon panel here, and thank you all for joining us.
Thank you so much, Austin.
Awesome.
Thank you very much, Austin. Thank you.